My name is Tim Walker. I work for Omicron Electronics here in the USA, and so I will be your host for today, and am looking forward to this webinar. So one of the things that I kind of want to basically go over is there's something that we call Ohm's Law. And so on Ohm's Law, everybody knows that you've got OHM is the way that it's spelled, and so Omicron is basically piggybacked on that 3 letters, and we use that as a 3-letter acronym. And so the O stands for the object file, the H stands for hardware, M stands for modules. So just real briefly and quickly, the object file is where you would go and put a lot of pertinent information that pertains to the substation. And so on that substation, you would put the station name, you would put the device that you're testing, you can put information such as locations, serial numbers, device of the actual element that you're going to be testing there. So you can put a lot of information pertaining to that substation. But also in the object file, you'll actually go out and set up some global type settings, such as whether it's 2-phase or 3-phase. Typically, we're working with a 3-phase system, but sometimes you may get into a railroad that may use some kind of a 2-phase system. But you also can put in there the frequency. You can also put in information such as primary values and secondary values for your CT and PT ratios out there. And so that's one thing that we'll be visiting during the initial part of the Quick CMC. The second part is hardware. Hardware is very important because you need to configure your test set to be able to use the proper currents that you want to be using. So it allows you to set up whether you're going to do 3 or 6 individual currents, or you can actually combine currents together to get any different values from basically 75 amps max to 128 amps if you're using a CMC 356. And then the last one we have there is the M, and the M stands for module, and module is the actual device that you're going to be working with. And so in this case here today, we are specifically working with the Quick CMC module. So with that, I'm going to go ahead and start up my Test Universe start screen. And on the start screen is where you can actually go and find Quick CMC. And Quick CMC, we're going to open that up, and we're going to go through each one of the parts of the Quick CMC. So once inside of here, on Quick CMC, in the upper left-hand corner, you'll see Test Object, and you'll see the hardware configuration. So going into the Test Object, as I mentioned earlier, we would come down here, and if you double-click on the word device, it's going to open up a window that allows me to put the information that I'd mentioned earlier. And so on the left-hand side is where you can put a lot of the information about your device that you're testing. And so it's just a nice way of documenting and keeping track of all the information for this specific device that you're working on. On the right-hand side, in the first box there, we can put in our nominal values. And so as I mentioned, you can select either 2 or 3 phases. You can select your nominal frequency. And then the VNOM is basically our line-to-line values that you're going to be working with in the secondary arena. And so this case here, if I put 120 volts in here, it's going to automatically give me the square root of 3. If I was only using 100 volts, I would put it in here, and it would do some calculations for me and give me line to neutral values there. Likewise, if I was actually to put 69 volts in here for my line to neutral values, I can get it to calculate my primary or my secondary phase-to-phase values. The next thing underneath that would be our primary values. And so whatever the primary value is you're using, whether it be 69 kV, 34.5, 138, 500, whatever your value or voltage you're working with at that point in time, you would put that in there as your line-to-line value. Or if it's a known line to neutral, you can put that in there. And then they basically go and calculate each other value based upon which one of those values you've entered. What this does is by setting up those two values in there later on in the Quick CMC, we can actually look at values in a primary configuration on our screen. But this here sets up our PT ratio for us and allows us to display that in primary values when we go and check that box to either look at primary or we can look at secondary values when we're doing our testing. The next box down, the iNom and the iPrimary, is going to set up our CT ratio. So typically most relays may look at 5 amps as a CT input into it. If you're doing reclosers, or maybe you have a relay that actually only has a 1 amp coil in it, you can set that to 1 amp. And then your iPrimary would be the primary value that you're going to be working with as far as currents are concerned, and that would basically set up your CT ratio from your primary to secondary. This next box down here that talks about residual voltage / current factors. When you look at these values up above, my V line to neutral over Vnom is basically the square root of 3. And then my I nominal, typically we would set that up as 1. So if you needed to change those values, you could do it. But those are the defaults that come through, and probably most of the time that's what you'll end up using. Down below that, we have limits. And so sometimes you may want to set up limits as far as the test set's concerned. I actually have a 356 that I work with, and so I've got my iMax set up as 128 amps. But as we all know, sometimes the relays are not going to be able to handle a large amount of current for a long period of time, so you may want to limit how much current that test set puts out by selecting your iMax there. Your Vmax is basically the maximum voltage. The highest level that you can get is 600 volts phase to phase, but typically you can get 300 volts for 3-phase constant out there. Then below that, we have our debounce and our deglitch filters, and you can usually set these up as your standards. These are the default values that come in. So if you want to set up your debounce time as 3 milliseconds, that's fine. If you need to change that because you've got some really bouncy contacts out there, you can choose to change those values if you run into some issues out there. And then on the left-hand side, we have our overload detection sensitivity, and that basically applies to the test set and how sensitive it is going to be for overload current conditions. So typically on a digital relay, you can set that as high. So it sets it as a minimum amount of 50 milliseconds. If you're using maybe electromechanical, you may want to change that. And if you go low, it sets it up at 200 milliseconds. So I'm just going to leave mine at high. So this is pretty much everything that you would do to set up your object file. So then here from this screen, I would say OK. I would jump down and say OK to get out of my test object configuration. And now this is the screen that you'll see when you're running Quick CMC. Let's go now into our hardware configuration. And so on a hardware configuration, usually when you're connected to a test set, and at this point in time I'm not connected to a test set, but you would see your model number that shows up, and then where the question marks are, you would actually see the serial number of your test set. And so the serial number of your test set can be found on the right-hand side of your handle on the machine, or you can look on the right-hand side, actually at the nameplate, and that would show you your serial number there as well. So the first thing that I would do is come in here and go into my details. And when I go into details, it allows me to select different configurations for my voltage and currents. So at the top, you can see I've got this set up for 4 by 300 volts. And off to the right of that, you'll actually see a configuration that shows you how the test set is actually going to connect, or how you can actually use the outputs on the test set. If I don't need that 4th voltage, I can come down and select 3 by 300, and that basically will only give me the 3 voltage outputs. And we only have one bank there, and so this would be channel A on our voltages if you want to look at it that way. If I only want a 300 volts, I could use 4, or that 4th output. If I want you can take and select some different configurations. Can everybody else hear me out there? They're all on mute. Can you guys hear me?
Yeah, you bet.
Good. All right. Just wanted to make sure I wasn't rambling on and talking to myself over here. So anyhow, thanks for replying. I think there's one person that's having some issues out there. They can't connect to me. But anyhow, I'll continue. All right. So if you wanted to get 600 volts, I could click on the 1 by 600, and it shows the configuration here where I would use output 1 and output 3, or phase 1 and phase 3. And it shows that my 3 would be my neutral and 1 would be my hot. And if I wanted, I can actually get 2 separate 600 volts outputs by connecting this configuration here. And I just want to make sure that I do not connect my neutrals together on these two because of the way that it's configured. And if you don't need to use voltages at all, you can come down and select not used. And not used will allow you to just turn off your voltage outputs. So for this example, we're just going to play around with the 3 by 300s configuration. Down at the bottom, I have a lot more configurations that I can use with the currents. And so depending upon whether I've got a 256 or a 356 or even a 353, you're going to have some different values here. So on a 356, the maximum current that I can get is 32 amps per channel. If I was using a 256, the maximum current that I could get would be 25 amps. And then on a 353, there's only 3 current outputs on it, but I can get 3 currents at 32 amps. So if I come through and look at this, the first configuration is 6 by 32 for my set. And so basically you're using all the outputs. And so the top row would be our channel A, which you can see is a designation. And our bottom one is going to be channel B. If I want to use basically these next 2 configurations, the difference between them is one selects channel A and the other one uses channel B. If I wanted to get 3 by 64, I can actually combine phase 1 of channel A and channel B together to get 64 amps of current from out of these 2 inputs basically parallel together. And then there are some other configurations in here. There's a 1 by 64, which is something that looks totally different. And then the maximum current I could get out of here would be 1 by 128 amps on a 356. And this would be 75 amps for a 256. And this would show you the configuration that you'd want to use. So in this case here, I'm just going to choose phase A currents of channel A and just use 3 of them. So once I'm satisfied with my configuration, I would then come in and say, OK, and I would come up and now look at my analog outputs, and so I've got 3 voltages and 3 currents, which is what I've got set up in my configuration. So the first column here is basically my output signals and where it's located on the set physically. The next column here that says display name is the display name. I can call it whatever I want. So just for the fun of it, I'm just going to change this last one. I can actually change it to anything I want, but I'm going to basically call it phase Tim. And just to show you what it looks like when you save this configuration back into the Quick CMC. And then over here, you would select which channel you're actually getting configured to it. My binary analog inputs is going to show how I can set up my binary inputs, and so whether I want to have a trip signal coming into binary input. In this case here, our trip signal is on binary input number 1, and I'm going to choose to turn off binary input 2. And so here again, you can change the display names, and what we've done is we've chose to use binary input 1 with a display name of trip. On this, you can set up whether you want a wet contact or a dry contact, or basically a potential free contact. So by using a potential free and clicking the box, it turns off recognizing any of the voltage inputs that would come into it, and it would be used such as a dry contact. If I uncheck that box, I can now set up what my nominal range would be. So if I wanted 125 volts, which is what my nominal voltage, DC voltage would be, that's what I would put there. If you have a 48 volt system, you could put 48 volts in there. And what this does is sets up your nominal value, and then down below you see this threshold value, and that is 70% of your nominal range. And what that means is anything above 88 volts in this case is going to register as a asserted, or basically a binary input is going to be active at that point in time. Binary outputs. On my binary outputs, if I choose, I can turn these on and off, and so I can select my binary outputs. Typically, the set only has 4, but on the back of the set, you've got some additional binary outputs that you can use if that's what you would choose to do. And then your analog inputs allows me to use the analog inputs part on that, and so I've got basically a voltage input plus or minus 10 volts, and I've got a current input which is plus or minus 20 milliamps on that one. So when I'm satisfied with my configuration of my hardware, I say OK, get out of here, and now I'm into my Quick CMC. So on Quick CMC, let me just unmute for a second here. Anybody got any questions? All right. We'll continue on here. On the Quick CMC screen, of course, you've got a menu bar up here. You've got some tabs, and up on this, you've got the Home tab, which shows basically the 2 things that we'd worked with was the test object and hardware configuration, but also it has other commands on there where we can start and stop our test. And also as far as doing some hold values, added reports, and some report settings. Under View, you can select what view you want to use. And so on the left-hand side, you'll see this test view. And then on the right-hand side, we actually can use our Phasor View, our impedance view, or our report view. And right now it's set up as Phasor View. And then also in this, you can choose to change it from cycles to seconds, or primary and secondary values, so on and so forth. And then the File tab allows you to save, import, export, and do some different things there with any of the configurations that you would choose in this quick CMC. So with this, let's take a look at our test view. And on our test view, you have this little table format, and it shows pretty much the currents and voltages that I've got configured. Now, if you remember on that phase C up there, I actually called it my name, and so this was just to show you that I can change any one of these things to match whatever you're using out there. So if you don't like a VA to N, then basically clean it up and change it to a different name if you want. But you do have that option, and that's what it looks like when you change that in the hardware setup. And then the next three columns inside of that, you've got your voltage and current magnitudes, which is what you can set. And then I've got my phase angle. And then off to the right here, the column, which you can't see, but I'll move it over, actually shows my frequency and what you're using there. So, if I was to choose to use the nominal values that I had set up in my test object, I could come up here and right-click in my first cell here, which on my phase to ground, and a window pops up, and I can select nominal values. And so that nominal value is going to be brought in and put into that cell for me. So it saves me a little bit of typing. If you're like me, typing, it takes too much, so you can just kind of select that off of it. Now here again, I could come and do the same thing with the next cells, but I want to make this more simplified. If I go back in there and do a right click, I can change this to equal magnitudes, and all three of those get filled in to that same value of that cell that I was working with. So let's say, for instance, I wanted to change cell 1 to 50 volts. And so now if I right-click on it and do equal magnitudes, it would change them all to 50 volts for me. So whichever cell I select or I right-click in is the one that I would change to. So let's just say I wanted to make C 60 volts, that's fine. But if I wanted to do them all the same, click on phase B, do equal magnitudes, and it basically fills in the blanks for me. Down here, I can do currents. In this case here, I'm just going to show some different current values. And I'm just going to put 1, 2, 3 amps in there. And I'm going to go back up and change my voltages to equal my nominal values. Likewise, you can do the same here with your phase. So I can select this at 0, but let's just say, for instance, I wanted to make this 30 degrees. If I change that to 30 degrees, right-click on it, I can actually come and balance my angles. So now it balances everything based upon the 30 degrees that I put there in phase A. And if I come back and select 0 and rebalance them all, whoops. And now basically that's just like what you would see in a normal system out there. So off to the right of this, you got binary outputs, and so if you were using binary outputs, what I could do is I could choose to click on one of the binary outputs, and when I click on that, that is going to close that binary output on the test set for me and allow it to basically feed into the relay if you want to do some kind of an indication, such as the breaker's closed or something of that nature. And to turn it off, I just simply uncheck it, and now it's basically turned off. To the right of this, you're going to have a phasor diagram, and on that phasor diagram, it's going to show you the configuration that we set up here in that table on the left-hand side. Underneath this phasor diagram, you've got analog inputs, and so this basically goes to those milliamps and the voltage from 0 to 10 volts. And if you fed some values into that, you could actually read those values on this screen. So on this table, you may have seen this thing called set mode. Set mode basically, we offer some different modes of operation out there, and it's really just the way that we display the voltages and currents or whatever we're looking at on our set mode. So on this, if we click on this, you can do a line-to-line value if you want. So if I click line-to-line, what you'll see now is you'll see my phase A to B value at 119 volts, which is what I set up for my values, and I had that for my line to neutral was set up at 69 volts. And if I want, I could look at symmetrical components, and so this is going to show my positive, negative, and zero sequence values for my currents and my voltages. If I want, I could use powers, and it's going to show power values here, watts and vars, both single phase and three phase. I could do fault values if I want. If I choose, I could do an impedance with current constant, impedance with voltage constant, or an impedance with our source impedance constant. And then you can do percent impedance here if you want. So I had selected powers here, and so when I went and done powers, this is showing that on phase 1 I have 69 watts with 0 vars, because basically I had 69 volts on there with 1 amp. 2 amps are on the second one here, and 3 amps are on the third one. And then this bottom one would be a combination of all three phases there. But this has changed it into a value that I would like to see here, but I still would like to know maybe what my test set is going to put out for these values of what I've got. So I can actually change these values in here by typing in numbers. If I want to get maybe 100 watts for all three phases, I can put 100 watts in there, and so you can manipulate values by applying the different numbers here. But one thing I wanted to mention was if you come way to the right here and look at my phasor diagram or my phasor view, there's a table here also here that looks similar to the one on the left. But the only difference with this one is this one actually shows the voltage and current that is being outputted from your test set. And so here's two different ways. And so if I wanted to know exactly what my currents and voltages were coming out of the test set, then this would show it to me. Likewise, at the bottom here, it shows me my phasor diagram of the outputs of my test set. And if you look over here, I've got my power values, and then also my phasor diagram is going to show my power in that window there. But typically, most people only work in the direct mode because that's kind of what everybody's used to, is just putting voltages, currents in there directly, and not being able, and that's kind of the way that we've manipulated a lot of the things out there. All right, moving down into my on trigger box here. If I get a trigger command from one of my binary inputs here in this center section, it's going to turn my test set off. And so by selecting this box, I can turn it off. If I don't want to turn my test set off, I uncheck it, and it's going to remain on. One of the other things I can do is when I check this, I can actually check it and have it switch off immediately. But if I want, I can change. Maybe I want to leave my currents and voltages on there for 2 seconds after I get a trigger. And so by putting 2 seconds in there, this will switch off, but I'll have a delay of 2 seconds out there. Down here in my step and ramp box, I can choose which value I would like to ramp. And so if I want to ramp my phases for my voltages, I can select any one of them here. I can do a phase-to-phase voltage, or if I choose, I can do all three phases at the same time. Likewise, I can do my currents, and my currents can be done either phase to ground, phase to phase, or three phase, or I could choose to ramp all the outputs if I want. So in this case here, let's just choose to do phase A to ground. And then I can select whether I want to do my magnitude or I want to do my phase angle. So we'll do magnitude in this case here. And over here off to the right, I have to specify what kind of a delta or size step that I want to do. So I want to ramp this up every 1 volt in this case here. So by selecting at 1 volt, I can come in here and now my 2 up and down arrows have been ungrayed, or basically they're black and they're active now. And so by clicking on this, every time I click it, it's going to change my voltage output by 1 volt. So I can either go up or down, whichever way I want. And it's just kind of a nice way to step through things one at a time. The other thing that is now active is this little box here. It's got a circle in it with 3 vertical dots, it looks like. But it's actually got a dot in the middle, and it's an up and down. Those actually, if you've got a mouse on your computer or laptop, and it's got a scroll wheel on it, the scroll wheel, you can actually use it to scroll up and down by the size that you've got. So if I've got a scroll wheel on mine, so if I scroll it up, I can, and I click the box to make it active, it'll basically scroll up and down every time I move my mouse dial. And then just turn it off if you don't want to use that one. Let's say that I don't want to push this button every time to ramp it up and down. I can choose the auto step function. And this function then turns on this time value. And under the time value, I can now change this into maybe every half second. And so now what I do is if I check the or click on the up or the down arrow, what that's going to do is every half second it is going to ramp it up and down 1 volt. And this may be difficult to see on your screen as far as timing wise, but it's just automatically ramping for me. Or I can ramp down if I want. And if I just uncheck it, then it'll stop it. So that pretty much takes care of anything as far as linear ramp is concerned. And then if I would like, I can select pulse ramp. And pulse ramp basically opens up this reset section here. And it allows me to use my up and down arrow. And I can do an auto step here. So by doing this configuration and setup that I've got here, is I'm going to play a voltage output for a half a second at 1 volt. And then it's going to turn off for a half a second. So my reset time is basically my my time off, and my time is my time on for my test set. And then if I hit auto step on this one, I can go up and down by using my 2 buttons here, my up and down buttons here. So what this does is when I do this, and if I've got my on trigger on to turn off the set, but if I come over here into my binary inputs, and if I check the box, and when I check this box of, because this is the only one that I've got defined and all the rest of them are not used, so it does not allow me to check those, is when I check that, what it's going to do is going to trigger on that one, but also off to the right here where it says NA, when I start my voltage or my current, every time I change my step, it's going to reset my counters reset my timer in the machine. And it's going to then give me a time over here if that input becomes energized or active. And so you have a trip command here, or a trip input, and then all the way, and so you've got from 1 to 10 binary inputs here, but I'm not using the other 9. And then also at the bottom, I have an overload condition. So if I overload that circuit, basically I want to trigger that one maybe to turn it off. And so I can check that box. And it's going to now turn my test set off based upon an overload condition. So that pretty much takes care of everything that I have in my test view here. Over to the right, we basically referred to this a little bit. And so my Phasor View shows me the outputs of my test sets. And so a lot of times, when people are looking at this, these are matching up since I'm in direct mode. And so it doesn't really show any difference on it. But as I showed going into a different set mode, it allows me to do different values for each one, but I can actually see what my test set's putting out. But the other thing is you've got this nice little Phasor diagram that you can look at down here and see what's happening vectorially on the diagram. At the bottom, I've got two other tabs that I can select in this view. I've got my report view, and my report view basically allows me to save any of this information out here into a report that I can save and use later on, or basically I can use it for documentation on what I just did with this test. Now the nice thing about with Quick CMC is every time I hit this add to report up here, it's going to add the values that are on this screen. And so you'll see the phases, the phase angles, the magnitudes, and all that information. You also have the date and time of when the test was performed, basically the username, the company. And here it would show you the test results and whether they passed or failed. So on a report, if I wanted to run a report, so over here, let's go back to my test view, and this is the setup that I want to apply to my relay. I would then come up here and hit my start button. In my start button, this is going to just do a simulation mode here for me since I'm not connected up to a test set. But my start button then basically has these values in here. And over to the right, you see now that I've got a trigger. And so I've got to trigger the command that happened on the rising edge, and it did it in 3.2 milliseconds. And so this information is something that I want to save as a test. What I would do is I would come up here and I would hit add to report. And I would come over and I could give it a title here. And so meter, I am using this for testing the metering on a relay. And so I can come down here and I could say, let's see if I can type right. And so if I were putting these values and I went and looked at my relay, I could actually confirm that the values for my voltages and currents matched, and I would come in and add it to the report. And once I was done with this, then I have to assess whether it passed or failed. And so in this case here, I would say that it passed. And typically I would not be using a trigger command when I'm doing a pass-fail. But after a second or two, you're going to see these values get filled into my test report. And so now with my test report, you see a summary here that says one test passed, and this one here passed. And at the top of my screen, basically it tells me how many passed, how many failed, and how many tests were not assessed. So this gives me some information about my different tests. So that's one that I put in there. Let's just go and say that we want to run this again. So I'll run another command here. I got this at 46 milliseconds here for my trip signal. I can now do an add to report. I'm just going to put some simple information here, but this time I'm going to fail it. And so now it's going to take all this information, stick it into my chart. And so now at my summary, you can see I've got one test passed, one test failed. And so this one here actually failed, but if I scroll up through here on my report menu, I can see this one here was metering, and this one here, I also kept this metering. I didn't change the title, but these are for two different tests that I had out there. And so on it, you can see it was in the direct mode. It showed my voltages, my currents, my phase angles, gave me a little Phasor diagram. It gave me my generator settings on what I was outputting. And then it gave me a value here for my binary inputs. So my trip was basically tripped off in 0.54 seconds. And so I'm showing this in seconds here. If I come up to this one here was like in 0.403 seconds. And so it's showing actually in seconds, but over here we actually saw it in milliseconds, but it's the same values that we applied to it. So I can add a number of these things to anything to document any kind of a test that I'm doing. So this is very powerful, and what it can do, you can test just about everything you want out there. You can even do differentials, but you have to put your own voltage and currents, or your currents in there for each of the different phases. And you can ramp them up and down. And if that's the way that you test your differentials, that works perfectly fine. One of the other things within Quick CMC is back in the test object, you'll notice that there was a distance function that came in, or a distance block. And so if I was testing a distance relay, I could put some settings in here. And so let's just say that the reach of my line yeah, I'm not changing it here. Maybe it's just because I didn't set this up ahead of time and I've already got some stuff in my reports. So let me come back out here. And let's go in here and clear my reports out. So now go back into my test object, distance. And what I wanted to do was change this to 10 ohms as a reach value at 75 degrees. And I'm not going to go into a lot of those distance functions here, but I want to add a new one here. And so now I come in and edit. I want to put a Mohs circle in here with a reach of, let's just say, 8 ohms. And it brings over my angle for me. It creates this nice little graph, and it brings it back here as an 8 ohm reach, and then it's got dotted lines, which is basically going to be my tolerances here, which is the information I can put down below. And on my tolerances, I can put also a trip time down in here. So once I say OK with this and say OK here, the reason I did that is when I come back to my impedance view, it now sets up this Mohs circle of 8 ohms, but if I had more zones there, on the more zones, it would actually show everything out there for me. And so what I can do now is I can actually come out and I can switch over to my impedance view. And I could select what fault type I wanted, phase to ground, phase to phase, 3-phase. And now if I want, I could come in and I could place a fault here just by clicking. So I could do one inside the Mohs circle, one side out. And I could just simulate some trips. So now just by clicking, you can see it's changing my window over here on my values. And if I wanted to go back to my Phasor view, and this is going to show me my currents and voltages that I'm outputting for that impedance. So it's a very quick and easy way of checking any impedance values out there if you wanted. I'm just going to go back to my direct mode, and so this is the values that I had in there last. So I had a current of 10 amps and a voltage of 87. And all that. That pretty much takes care of everything here in my the large majority of the screen. If I come up and look at some of the stuff at the top, I can actually put a pre-fault value in here by clicking this tab. And then I've got the start and stop. If I start something, I can also hit start again, and it's going to stop it. Or if I hit start, I can hit the stop button right next to it to turn off my test that I'm working on. This next one basically allows me to do hold values. So if I basically have this connected to a set and I click on my hold value, what it does is it keeps those values that I've got currently set up here being applied to my relay. And now I could come in and change this to maybe 10 volts, whatever I wanted. And now when I uncheck my hold box, it now is going to apply this configuration that I've got now. And so you can kind of do some quick and simple fault values in here if you know values that you want to basically use to actually get a trip onto your relay. We talked about the add to report. Once you add something to a report, it puts it into my report view. If I want, I can come in and hit clear report. But keep in mind, when I hit clear report, it's going to clear everything that I've got in there. So if I got multiple values that I've tested, then they would all get cleared out. So you would either do one at a time, or if you want to do multiple ones in here, say maybe you want to do phase A, phase B, phase C, you could go through and it would capture all three of them on the right-hand side for me. I've got the opportunity to put an overall comment in here if I want for the whole assessment on what I'm doing. And then the other one here, I can actually do report settings. And we have two basic default report settings. One is a short form and one is a long form. So right now we have short form selected. If you look over here to the right, there's not a whole lot of information there, but maybe that's what you want. If I choose long form, it can come back through and take those values that are in there and actually convert it over to the long form based upon that. So now you can see that a lot more information was added into my report. If neither one of those works for me, I can come in and hit my define button. My define button allows me to come in here and expand values out. And I can check and uncheck different parts of the test report that I would like to see. And I could say then OK, and now it's going to go and clean this up. If I want, I can actually save values once I define this. I can actually add a name to it. So if I hit add, I can give this a name. And I've copied it from the long form and say OK, and now I can come in and check what I want and what I don't want on. And hit OK. And now you'll see that I've got a third item in my list now that maybe it's something specific to what you guys want to do or see as a report. So that's everything pretty much on this tab. My view tab, here again, I've got my test view, which is on my left, my phasor views, impedance view, report view, which I've gone through those already. Status history and overload monitors are at the bottom. And so this allows me to look at some stuff that's going on. The status history kind of tells me what's going on with my test set. And the overload tells me kind of whether I'm overloading my currents or my voltages here. And so these are all green, OK, but if they aren't OK, they would turn red for an overload condition. Then I can choose whether I want cycles or seconds. And basically, it's going just to change the way that the information is recorded for my trigger. I can select primary and secondary values. My primary values, I can show this in the primary values, and all this stuff is based upon what I had set up for my CT and PT ratios out there. And a lot of times if I'm doing reclosers or even relays, maybe I want to see these values as primary values because that's what it shows on my metering. And then I could come and choose this window, and it's just easier for me to look at the values instead of getting a calculator out and calculating the values that I want to see. Then I can select absolute and relative out here. Usually it's just defaulted to absolute values. And then let's just say that any one of these windows that I would like to see maybe full screen or larger, I could just double click in the blue area and expand it out. If I just double click again, it takes it back to what it was. Likewise, in my report view, I could double click and expand things around. You can also use the typical Windows commands here to actually go and manipulate the windows here. let's say that my voltages and currents, this is what I wanted to save, and this is kind of a generic report that I would like to use many different times. I could come up and do File, whoops, and do a Save, and this would save it now as, it's got a default name here of Quick CMC, but let's just say that we called it Webinar just for what we're doing here today. And it puts an extension of .qcm, which is Quick CMC module. And now if I hit Save, if I come back into File now, on my right-hand side, you'll see my recent files. And so I can choose this one and call it up. And this would have all my configurations in it. So this would include my hardware, my object files, all this other good stuff in here. You know, my magnitudes, whether I'm using these trip values and what they're set to. And now I can run this as a later test. I could do a save as, just kind of your typical Windows commands. I can export my report or export the data. And if I choose, I can print this. I can do a print preview. I can do my page setups. And those are all pretty much just kind of window commands that you've got out there. With this, basically, that's all I have as far as my presentation is concerned. If anybody has any questions, I will unmute everybody and feel free to ask a question. Alright, so if I don't have any questions, I appreciate everybody for participating today and showing up. And I hope this has been valuable for you and you can actually take this and use it in testing out there. Maybe if you don't have a test set, maybe it's good for an evaluation process for what you can see. But here again, this is just kind of a quick and easy way of showing stuff out there on how to use this one. Most manufacturers will have some kind of a basic screen out there where you can actually manipulate voltages and currents to do what you want. So anyhow, thank you guys. Have a safe day out there, and look forward to seeing you on another webinar out there. If you guys have a question that you'd want to send to me afterwards, my email address is tim.walker, WALKER, at Omicron USA, that's all one word, .com. And so feel free to contact me with any questions out there that you would have. Got to have a comment there that the forums are helpful, so you can go out there and get onto our website and ask questions out onto the forum out there if you want. If you also need help, you can go to our, you can call the 1-800-OMICRON, and somebody will be there to assist you. We have a 24-hour support line, 7 days a week, 365 days a year. So somebody will always be there to help you out. With that, have a nice day, and we'll talk to you later.